So welcome everyone to a new session of Talk to the Expert, why Kubernetes is an ideal for the industrial edge and what is a better way. My name is Miriam, Head of Marketing at Barbara, and today we are going to challenge a common assumption. The assumption that is that Kubernetes, the de facto standard for cloud-native orchestration, is also the right fit for edge computing. Well, it is not, and we will show you why. Joining me today is Kike Ramírez, Senior Solution Architect at Barbara, who will walk us through the key differences between an edge-native platform built on lightweight Docker-based architecture and a Kubernetes-based edge infrastructure. You will see why the choice of orchestration technology matters, especially at the edge. So welcome to this talk, Kike. Happy to have you with us today.
Hello, Miriam. How are you? Let's start comparing both tools, Kubernetes and the network orchestration tool like Barbara. So I will share my screen with a small presentation we have prepared for today. Let's start. Kubernetes has become the gold standard for orchestration applications in the cloud. But when we bring those same principles to the industrial edge, where devices are heterogeneous, connectivity is unreliable, and operation must be secure and resilient, Kubernetes often falls short. Today, we will explore why that's the case and, more importantly, what solutions are better suited to meet the unique challenges of the industrial edge. Okay? So let's start with the definitions. Basically, Kubernetes is an open source platform that automates the deployment, the scaling, and the management of containerized applications across distributed systems. It abstracts the infrastructure into a single cluster, enabling self-healing, load balancing, and scalable declarative operations. Barbara brings that same orchestration power, but to the industrial edge. It simplifies how applications and AI workloads are deployed and managed across diverse edge devices while ensuring secure, resilient, and offline-capable operation. With its centralized control panel and ecosystem of edge-optimized apps, Barbara accelerates AI adoption where it matters most, which is at the edge. Let's look at architecture and design. Kubernetes was originally created for the cloud and data centers, environments that assume stable connectivity and plenty of compute resources. While there are lightweight distributions like K3s or others that try to adapt Kubernetes to the edge, it is not optimized for constrained devices or challenging environments. Barbara, on the other hand, was purpose-built for edge computing from the ground up. It's designed to operate in environments where latency is critical, bandwidth is limited, and connectivity can be intermittent. And unlike Kubernetes, Barbara natively supports heterogeneous hardware, where it is Intel server, ARM devices, or AI accelerators like Jetson, making it truly fit for industrial edge realities. When it comes to node management and deployment, Kubernetes offers a lot of flexibility, but that flexibility comes at a cost. Managing remote or disconnected edge nodes requires heavy customization, and typically you need to extend Kubernetes with frameworks like KubeEdge or K3s to make it viable at the edge. On top of that, keeping production deployment stable demands advanced DevOps and cloud-native expertise, which many industrial teams don't have in-house. Barbara takes a different approach. It provides a centralized control panel with built-in support for registering, provisioning, and monitoring nodes. Features like over-the-air updates, hardware management, and offline resilience come out of the box. The result is lower operational complexity, making it accessible not just for DevOps experts, but also for OT teams who need a straightforward, reliable way to manage edge environments. In edge operations, Kubernetes runs into some fundamental limitation. It assumes continuous connectivity between the control plane and the worker node, something that's not guaranteed in a virtual environment. While projects like KubeEdge can extend its capabilities, operating offline or with intermittent connection remain a real challenge. Kubernetes also provides a strong security feature, but reaching industrial grade standards usually requires traditional manual hardening. Barbara was designed with these realities in mind. It supports offline first operation, meaning workloads keep running even if connectivity drops, and everything automatically synchronizes once the connection is restored. It is also tailored for OT and IT convergence, bridging the gap between industrial systems and modern IT practices. On top of that, Barbara comes with the built-in security mechanisms aligned with AI 62443, so industrial-grade security isn't an afterthought, it's part of the platform by design. When we look at ecosystem and extensibility, Kubernetes clearly shines in the cloud-native world. It has one of the largest and most mature ecosystems, with integration for thousands of tools covering observability, CI/CD, autoscaling, and more. It is highly extensible, but that richness comes at a price, bringing significant operational overhead when you try to run it in constrained edge environment. Barbara takes a different path with a focused ecosystem built specifically around an industrial edge AI use cases. This included domains like monitoring, computer vision, predictive maintenance, streaming analytics, and cybersecurity. Through its proprietary marketplace, it provides pre-built application optimized for edge workloads, reducing the need for heavy customization. While the community may be smaller, it is highly specialized, concentrated on real-world industrial edge deployment rather than general-purpose cloud workloads. When it comes to cost and time to value, Kubernetes appears attractive on the surface because it is open source and has no licensing fees. However, the hidden costs can be really significant. Organizations need to invest heavily in engineering, maintenance, and constant tuning to make it reliable at the edge. This often results in a slower time to value, unless the company already has a measured Kubernetes practice in place. That said, Kubernetes remains very cost effective in hybrid or cloud environment where it is already the standard. Barbara, by contrast, is designed to accelerate time to value specifically in industrial edge scenarios. With its simplified learning curve and built-in capabilities, organizations can move from pilot to production much faster. This reduces operational overhead and enables OT and IT teams to deliver business outcome quickly without the steep investment in specialized DevOps skills. Okay, let's talk about some customer pain points we normally see when they are using Kubernetes-based tools. The first challenge is complexity. This tool comes with a steep learning curve, making it difficult for new staff to adopt. Cluster and node management are cumbersome, and organizations often need heavy customization, for example, building their own service mesh just to meet their needs. Reliability is another issue. Service interruptions are frequent, and downtime directly disrupts 24/7 operations, leading to financial losses. On top of that, communication around critical updates is often lacking, which only increases the risks. There is also a strong dependence on niche expertise. Running this tool requires highly specialized Kubernetes skills, which means organizations often lean on external consultants. And even then, providers don't always fully understand operational priorities from the OT side. Finally, these tools are simply a misfit for industrial edge environment. OT team values simplicity, robustness, and uptime, but they bring complexity instead. It also lacks advanced capabilities like built-in AI/ML or predictive maintenance, and there is no marketplace for ready-to-use industrial application. This leaves organizations with high effort, high risk, and limited value at the edge. To close, Miren, let's bring everything together, okay? Kubernetes is a strong choice if your organization already runs a major cloud native stack and wants to extend that model to the edge. But it comes with trade-offs. It requires significant engineering effort, specialized expertise, and it isn't optimized for resource-constrained or disconnected environments. Barbara, on the other hand, was designed specifically for the industrial edge. It minimizes complexity, supports offline-first operation, and provides simplified node and workload management out of the box. Most importantly, it accelerates deployment and delivers reliability in environments where uptime and resilience are non-negotiable. In short, Kubernetes is powerful in the cloud, but Barbara is purpose-built to make the industrial edge both practical and productive. Using a visual analogy, Kubernetes is like a massive cargo ship, extremely efficient for moving goods across open seas where the waters are deep and stable. But the industrial edge is full of shallow waters, narrow canals, and unpredictable currents. In that environment, you don't need a cargo ship. You need a fleet of smaller, agile boats designed especially for those conditions. That is just what Barbara provides to you. Barbara, at the end, it isn't trying to retrofit Kubernetes. It's a whole new platform built for the realities of the edge. It offers AI model lifecycle management, industrial protocol support, and robust OTA, all in a secure, lightweight, scalable platform. So, well, Miriam, I think it's all. What do you think?
Well, very illustrative indeed. Thank you so much. We've seen that Kubernetes, yeah, as powerful as it is in the cloud, isn't designed for the unique challenges of the industrial edge. That's what I got from this talk. For our audience, if you're ready to see what this could look like in your operations, at Barbara, we are more than happy to book a demo, a personal demo. And thank you again for joining us today. And we look forward to welcoming you to our next session in our Talk to the Expert that we hold every month. Thank you so much to all. Bye-bye.
Thank you, everyone.
Bye-bye.
Bye-bye.
Bye-bye.